an example of the system writing a full minute of samples and saving to the SD card. So we're going to get 60 samples displaying once a second, and we will have a minute. We get a message to our queue, our event queue, and we will write all of that to the SD card. And whilst it's doing that, we'll select the parameter just to prove that none of our functions are blocking and we can do all of it at the same time. So currently, all the LEDs are lit up because that's the default state for the LED bar driver. So we can just type straight into our terminal here. And the function is just select, select space, open a bracket. We can choose a parameter. It has to be capital. So we're going to choose lights. And we can close that bracket, and that's our enter key. And that's interesting. What did it do there? Oh, right, that would have been the first initialization of the SD card, as it's quite slow doing it the first time. But we'll go again and we'll just prove that's what it was. But yeah, as we can see, it's now displaying the quantized data of our LED value of about 0.54, so it's about 54% through our LED bars, which looks about right to me. If we hold this down, we'll see the number drop up to close to 100, so it reckons it's about 0.9. So yeah, it's probably 90% of our LEDs lit up just there. As we remove our finger, it'll drops in line with the samples. So yeah, as you can see, it's slowing down. Obviously, to do the SD writes, it's a time-consuming process. Yeah, just to prove like we can just spam our input function and still solidly once a second we get our samples through. Not a problem. And a nice feature of the buffer is we can do some cool stuff, like because we close our SD file, what we can do is just remove the card. It's a bit awkward. Oh, come on. As we can see, the system is still running. The card is removed. And it will just keep going. It will just exit. Eventually, it's going to fill up the buffer. And what it will do is reset once it fills up. So we'll just leave that to run to fill up the buffer a bit. So it's trying to write now, but it's going to exit. It's not going to be able to continue. And we should see a nice system reset. Or maybe not. There we go. We've got our open file error. It was there waiting, trying to do it. And we'll fill up our buffer. There we go. Oh, we just missed that. So it prints an error to the terminal from our function just in here where we get our counts. It tries to write to the system just to clear out the buffer, just in case we're right next to a sample flush. So what we can do now is we can plug this card back in. Ooh. God, this is fiddly. Yeah, what we missed there a second ago was the lights turning off here as it did the what is a soft reset where we clear all the buffers. So we just wait now just to prove it all still runs. So obviously writes take a bit of time. It is a slow process, and obviously displaying write to the terminal isn't slowing our program down. All gets slapped onto a message queue. And as we can see, it's succeeded with that right, noted by the little done notation we've got here. This isn't necessary, it's more for debugging and proof of concept purposes. So what we're going to do now is we're going to go ahead and reset the system. And yeah, as you can see, we've got previously latched data from our latches, because that's just the last state that we're in. So we can go ahead and select another parameter. Square bracket, any letters, we can go for a H. Close brackets. Oh, I should probably clicked on the terminal, be a lot more useful. So we go ahead and select, and we'll go for, it has to be capital for parameter. We can close the bracket and we press our enter key. See, we've got a little confirmation here that is blocking because it's just running a normal printf. It's just from a function that's just for debugging purposes. But we get a display of our humidity, which is nice.